All right, guys. Hey, this is less than ideal. My voice is still kind of gone, and I'm hoping to be back as soon as I can. But I want to be there to help you guys out. So I know there's probably 1,000 questions. We're working through proofs, and I know those are hard. But I wanted to give you this lesson to get the ball rolling a little bit on this, to give you time to think. Please don't panic in any way, shape, or form. As soon as I come back, we will take our time to really review this. If anything, hooray, this is giving you more time to kind of get those theorems and postulates and definitions down, okay? But again, I wanted to give you something to get the ball rolling in this section here. Really, all we're doing today is finding the distance between two lines, okay? And in order to do that, we need to know this concept first. That the distance between a point and a line, if I was looking at these pictures, which one is the actual distance? Well, it's the shortest distance, which is this blue line. It always will be perpendicular. So when I measure my height, if you went to the doctor, they would tell you, hey, stand up straight, right? The idea is that what they really mean is don't lean over, don't hunch over. And so you're not doing any of these diagonal lines, okay? You're standing up straight, perpendicular to the ground. So if I want to find the distance between, say, a point and a line, like I have here, that was a terrible line. I want to find this distance right here. Okay? That's what we're going to do. And in order to do that, we're going to take into consideration this postulate. There's exactly one line that's perpendicular. So the question is, how do we find that line so we could find this distance? Okay. So same idea. The distance between two parallel lines is the perpendicular distance between them. So if it looks something like this, there is this theorem that says this. Listen, if you have two lines that are equidistant from a third line, so what they're saying is 1 and 2, notice the numbers here, number 1 and 2, are the same distance from line 3, then they must be parallel. So what they would do on a problem like this is they would say, find x so that 1 is parallel to 2. Okay, and the idea is all I would have to do is set these equal to each other. Okay, I'm going to let you do the math there. I'm going to save my voice. I believe in you guys. You can handle that problem right there. Okay, this is what I want to focus on. And I'm sorry this yellow is a little bit wonky, but okay, we're going to do how do we find the distance between two parallel lines? And it's I have 5-step process. Okay, I don't mean that for those 5 steps to be overwhelming. I mean them to be clarifying, instructive for you. I'm gonna change this yellow really quick to a goldenrod. Y equals 2x minus 3. Okay, hopefully that's a little clearer for you. So let me actually do this really quick. All right, so the idea is this, listen. Step number one, always, all the time, just graph, okay? Graph your equations. And the reason I say that is because sometimes when you graph these, they turn out like this. And if they turn out like that, you could easily just count the spaces, right? 1, 2, 3, 4, 5. Okay. If they're diagonal, like we've got 2 here, and I'm going to graph them really quick, okay? Be better if I had graph paper. But I don't. I'm going to graph this on the side here. Oh, that was weird. Sorry. If I were to graph these, you've got your red line that's starting at positive 1, 2. And it's going up 1, 2 over 1. Up 1, 2 over 1. Okay? Doing these on graph paper is 10 times better than what I'm doing right now. All right? And the reason I say that is because if it's on graph paper, everything's going to become a little more crystal clear for us. That other line starts at negative 1, 2, 3, and goes up 2 over 1. Up 1, 2 over 1. So it looks like this. Now, couple thoughts. Okay, let me kind of zoom in on this picture. You cannot, no, bad, don't do. 1, 2, 3, 4, 5. You can't do that. Those spaces, especially if you look out on graph paper, are not nice. Like, you're counting up and down, but that's not the distance between these. We want the perpendicular distance. Okay, so I've got to figure out this perpendicular distance. That's not always easy. Even right now in my picture, this is not nice. It's not going nicely. So we got to kind of figure this out. So here's our 5 steps, okay? And I'm going to go through them this way. You can write them all here. I'm not going to do that. I'm going to show you here, okay? So step number 1, they're already listed out for you. Find the perpendicular slope of a point on one of the lines. So we're going to always use our first line, which I'm calling the red line. Okay. Y equals 2x minus 3. That's my other line here. But I'm going to find for the red line my perpendicular slope. So my slope of this one is, the red line is 2. So perpendicular, we want the opposite reciprocal. Which is going to be -2. That's my slope. Oh, sorry. -1/2. I'm not doing push-ups at home right now, by the way. Okay. All right. And you need a point. And the point can just be the y-intercept. So 0, 2. Okay. So we're going to take the red line. We're taking it apart. Tell me what the slope is of that line. Tell me what the y-intercept is. All right. Step number 2, we're going to make a new line. We're going to use this to make a new equation. And slope-intercept form. Y equals -1/2 x plus 2. Okay? If you don't want to do this, you can jump straight to this. All right? Now, what we've done is we've created our blue line. It starts here. It goes down 1 over 1, 2. Down 1 over 1, 2. Okay? Now, this is the other reason we graphed this. Notice when I went down 1 over 1, 2, it made it very obvious that there's a point that this touched. So, we just drew this line, but really what we're focused on is the distance here. That means all I have to do is find the distance between these 2 points. There are times where this is super easy and obvious. It just hit this really nice coordinate. Yay! Okay? And if it did that, all I have to do now is find the distance between this point, 2, 1, and 0, 2. Okay? And that's what I'm trying to explain here. Okay? It says like, if that's nice, okay, if that's a nice coordinate, and let me just take this picture here, and let's drag it down here. Blow it up a little bit. If it hits 2 nice points, you could actually stop after step 2, and all you'd have to do is find the distance between 0, 2 and 2, 1 using the distance formula, okay, or using Pythagorean theorem. So the distance formula is this: y2 minus y1 squared plus x2 minus x1 squared. You guys learned this last year. It's been a while. So you could plug in those coordinates. 1 minus 2 squared plus 2 minus 0 squared. Okay. Just to label that really quick, x1, y1, x2, y2. Okay. So you end up with -1 squared plus 2 squared, and you end up with 1 plus 4. That's 5, and the square root of 5. We're going to get a lot of square root answers, not nice numbers here. Okay, that's the distance between these two. This is our answer. Okay, however, finding that point, like we found here, is not always that easy. So the remaining steps are actually designed to help you find these things. Okay, so let me walk through that. Here's the other steps. What you're going to do is take your blue equation, y equals 1/2, -1/2 x plus 2, and your yellow equation, goldenrod, and we're going to y equals 2x minus 3. And we're going to set those equal to each other. Okay? Negative 1/2 x plus 2 equals 2x minus 3. All right? And so I'm setting those equal to each other, and I have to solve for x. In order to do that, you can multiply everything by 2 if you want to get rid of your fraction. I'm just going to deal with the 1/2 here. Sorry, 1/2 x. And I'm going to add 3 to both sides. I'm doing 2 things at one time, okay? So the 3 goes away here. It's going to come over to the left. You get 5 equals 2 and 1/2 x. And hopefully you know your multiplication tables enough that dividing both sides, with purple here, by 2.5, okay, x is going to equal 2. Now, notice that's not a surprise. What are we looking for right now? We're looking for this coordinate, this green one that's circled here. And what was the x coordinate? It was 2. That's the number we just found. That's nice, okay? Notice, now I want to find the y, which I'm expecting to be a 1. Sorry, I'm blurry. Oh, so I'm going to plug in. Guys, I sound like some of you last year. You remember that when your voice was all cracking? Y equals 2x minus 3. Well, x we just got was 2. So I'm plugging that back in. So we end up with y equals 4 minus 3, y equals 1. Okay? So there's your coordinate 2 from this one, 1 from this one. That's your other coordinate, and we use our point from step number 1 to figure that out. Okay, this is a long process. Listen, 90% of the time, the problems are going to be like this earlier one, where it's like, it's nice, and you could just do slope. You could just do distance formula right away. I think on the test, I'm going to give you one of each, an easy one and a hard one. Okay, I'm not saying this is easy. It is a process. So this is kind of a summary, and what I'd like you to do, you guys, as best as you can, I want you to try. I tried to make the instructions as clear as I can, okay, to do that for this one. So again, really quick, notice I graphed it, and here's the issue. I'm trying to zoom in as much as I can. The issue is that this guy right here is not a nice point. It's not even a half, I think. It's like a decimal. So that's what we're going to run into, okay? So let's do this kind of like walking through. So we want the slope of the red line, which is 3, but I want the opposite reciprocal. So I'm going to transfer that. Here's my slope, 3. I'm going to transfer that to negative 1/3. And I want a point from that, which is 0, 4, my y-intercept. Step number 2, I make a new equation and I graph it. So my new equation, y equals negative 1/3 x plus 4. That's the blue line. Now, if I graph it and that purple point here was nice, I would be like, yay, hooray. But it's not nice. So what we have to do is step 3, 4, 5. On step 3, 4, 5, I want to make sure it's clear. What we're really trying to do is find out, where do these two lines, where does the blue line and the yellow line intersect? Okay? Maybe when I get back, I'll show you on graphing calculators how that works. That would be nice, and it does work nice. All right, so what we're going to do, I'm going to do it down here. I'm going to set this equation, 1/3 x plus 4 equal to my yellow one. Okay. 3x minus 4. And this is how we figure out what is that coordinate. So on this one, what we're going to get, if I start to solve this, same kind of idea. I'm going to add 4 to both sides. And I'm going to add 1/3 to both sides. Okay, I put my x's together and my y's together. So 8 equals 3.3333 repeating x. So I'm going to pull out my calculator. I have no idea, you guys. 8 divided by 3.33333333. I'm putting in a lot of threes, okay? Like a ton. All right. You end up with x equals 2.4. That's actually not too bad. All right. So the x coordinate of this one is 2.4. I just need to figure out the y. So that's the next step, is to plug into the yellow equation. So let me get my yellow equation back out. Okay. Here's my yellow equation. I'm running out of space here. Y equals 3x minus, is it minus 4? Minus 4. And my x value was 2.4. So 2.4 times 3 minus 4 is 3.2. Okay, so I just multiply that out and solve. So 7.2 minus 4 is 3.2. Okay, so you've got this new point right here. Notice, use this point, x from step number 3, y from step number 4, okay? And the point from number 1, which is this red one, and do the distance formula. So now the rest of the time, I want to say all we're doing, is the distance formula. We got 2 points. 4, 0, and 2.4, 3.2. I'm using the distance formula. And I'm going to let you guys plug in. You guys can do this. 3.2 minus 0 squared plus x1, y1, x2, y2. 3.2, oops, sorry, x2, 2.4 minus 4 squared. Okay, and punch that in calculator by hand, however you want to do that. Careful. Be really careful here. When you're doing your math, you're going to get negative 1.6. When you square that, put it in parentheses. Or remember, a negative times a negative is positive. If you do this on your calculator, it will give you the wrong answer. Okay, it's going to give you negative 200 or 2.56. You want positive 2.56. Okay, so be careful about that. All right. All right. So that's it. I just wanted to introduce this. I feel like I'm trying to be clear in the video. It's hard. This is a process. Okay. So again, on your test, I know there'll be an easier one, like the first one, where it was like you do step 1 and 2, and when you graph it, you're like, magic. These 2 spots are really nice. And there'll be one that's a little harder like this. So the steps are just designed to help you have something to walk through. All right. Please don't panic. Okay. That's the worst thing you can do. Try the homework. Yes. Don't spend more than a half hour on it. Okay. And hopefully that'll be enough just to get the ball rolling, and we'll pick up next week going over these things. Okay. I wish I could be there. I want to help you out. I will do everything I can when I get back to work, as hard for you guys as I can. All right.